I'm Kirsten Newham, Interim Chief Curator at the Oriental Institute Museum of the University of Chicago, and I will be hosting today's talk. A few words of introduction to the OI, if you're unfamiliar. The Oriental Institute of the University of Chicago is both a pioneering interdisciplinary research center and a world-renowned museum whose aim is to understand, reveal, and protect the earliest civilizations of the ancient Middle East. With 350,000 artifacts excavated mainly by OI archaeologists, the OI Museum houses the largest collection of ancient Middle Eastern antiquities in the United States. Since its founding in 1919, a time when the Middle East was called the Orient, the OI has pioneered innovative excavations and comprehensive dictionary projects that serve as cultural encyclopedias of ancient civilizations. Of the 350,000 artifacts that make up the OI Museum collection, about 5,000 are on permanent display in the main galleries, which are divided up in regions of the ancient Middle East. In addition to the artifacts, the OI Museum collection also encompasses an expansive archive collection composed primarily of materials related to the OI expeditions of the early 20th century, as well as field journals, object logs, and archival photographs of excavations and objects in situ. Additionally, the OI collection also includes more contemporary art pieces, including large-scale paintings of archaeological sites as well as photographs. The breadth of the collection is perfectly represented in our current special exhibition, Making Sense of Marbles, Roman Sculpture at the OI, which inspires today's talk. So a few words about the exhibition. On view as a group for the first time, the OI's collection of Roman sculpture illustrates how we can make sense of marbles with divergent histories and the fundamental importance of archaeological context in telling an object's story. The majority of the collection was excavated by OI archaeologists at the site of Ptolemais in Libya in 1956 to 1958, a veritable highlight being two life-size marble statues once displayed in the city baths at Ptolemais. In the exhibition, this abundance of contextual information is placed in sharp contrast with Roman works purchased from the antiquities market. 65 years after they were first on view in the galleries of the OI Museum, we can appreciate the OI's collection of Roman marbles in a new light, conscious of their complex history. And the exhibit was co-curated by myself and Rocco Remora, PhD candidate in the Department of Art History at the University of Chicago. Now, without further ado, I would like to introduce our speaker today. Alison Whyte is an objects conservator at the OI, where she has specialized in the preservation of archaeological material from the ancient Middle East since 2001. She is a graduate of the Queen's University Master of Art Conservation Program and also holds a BA in anthropology from the University of British Columbia and an MA in ancient studies from the University of Toronto. In addition to her on-site work at the OI, Alison has participated in field projects in Italy, Cyprus, Turkey, Israel, Afghanistan, Spain, and Uzbekistan. And now I will pass it over to Alison for today's talk, Venus with Cupid, Discoveries from the Conservation Lab. Alison?
Thanks, Kirsten. Thank you all for joining me today for what I hope will be an interesting presentation. We wanted to give you a glimpse of some of the work that the Conservation Department does, and in particular, what we did in preparation for the OI's current special exhibition, Making Sense of Marbles, Roman Sculpture at the OI, which opened in September of this year and will continue until next spring. This talk will focus on this small stone sculpture dating to the Roman period, 2nd to 3rd century AD, which depicts the goddess Venus holding a lock of hair in her right hand, although the connection to her own head is no longer there, while Cupid stands at her left side beside his quiver with his hands bound behind his back. The statue measures about 35 centimeters tall, 13 centimeters wide, and 7 centimeters deep. The first step in any conservation treatment is to examine not just the artifact itself, but the artifact's history. Where is this object from? How did it get to the OI? What's happened to it since it was first made? Is there evidence of previous restoration or conservation treatment? And what's been done, and who might have carried out this work? Concurrently, we want to learn as much as we can about what the object was originally made from. The answers to these questions will have an influence on how we approach any conservation intervention. When researching the history of an object, conservation will look to several other departments in the OI to get information. We work not only with the curators for the exhibit, in this case, Kirsten Newman and Rocco Remora, but we also consult our registration records and the OI archives. Registration and archival records indicated that the Venus and Cupid statue was purchased together with this life-size statue of a boy. Both were bought by former OI director Carl Kraling in the 1950s in Beirut, Lebanon. Kraling used funds from Mr. and Mrs. Hans von der Marwitz, and the sculptures were exported with the permission of Lebanon's Department of Antiquities. On the left in this slide is an image of the invoice from this purchase dated March 21st, 1957. The invoice provides no provenience for the boy statue, but the Venus and Cupid sculpture is said to have been found in Rostan, which is a reference to the town of Al-Rostan, known as Arethusa in Hellenistic times, which is near Homs in modern-day Syria. From the OI accession card dated to July 5th, 1957, and shown on the right in this slide, we learn that the items were acquired in Beirut, Lebanon from antiquities dealer Eli Bustan. Note that the accession card describes both the boy statue and the Venus and Cupid statue as having been found in the vicinity of Baalbek. So there's some conflicting information here, which highlights one of the many difficulties in trying to understand the provenience of purchased objects. This is in fact one of the main themes of the Making Sense of Marbles exhibit. Was the statue from Al-Rastan, as indicated in the invoice, or Baalbek, as the OI accession records indicate? Baalbek was a famous oracle pilgrimage site in the Roman period when it was known as Heliopolis. And the remains of its impressive temple complex meant it would have been a very well-known archaeological site in the 20th century when the statue was acquired. Rocco Remora, in his presentation for the opening of the Making Sense of Marbles exhibit, suggested it was possible the dealer who Kraling purchased the statue from might have suggested Baalbek as a provenience in order to raise the market value of the object he was trying to sell. Rocco also noted, however, that Al-Rastan, or ancient Arethusa, an important city in the 1st century BC, was certainly as, if not more, plausible as a find spot. Unfortunately, as is the case with most purchased antiquities, the circumstances surrounding the discovery of the object are unclear. OI archivist Anne Flannery was also able to find these early photographs, which she thinks likely date to the time period when the object was acquired by the OI, so in the mid to late 1950s. Here's a side-by-side view comparing the earlier photo with how the object appeared when it came to the conservation lab earlier this year. It's hard to compare color and black and white images, but more or less, it looks like it's in the same condition. And I'll go into more detail about the condition a bit later, but for now it's enough to note that the object has been repaired from several pieces. There's damage to the lock of hair held in Venus's right hand. A white substance has been used to fill some of the gaps around the joins in the right arm, neck, and other areas. In short, the repairs and restoration that were apparent when the object came to conservation earlier this year look unchanged from the earlier photograph. We were also able to find out that this object was exhibited once before at the OI in 1957, as indicated in this communication. And here's an image of graduate students visiting that 1957 exhibit, which also featured these larger marble statues. These statues were excavated from the site of Ptolemais in Libya and are part of the Making Sense of Marbles exhibit. We also know that the Venus and Cupid statue, along with several other objects in the current OI exhibit, were lent to the Smart Gallery, now the Smart Museum of Art, also on the University of Chicago campus. This is a communication from 1973 between Gustavus Swift, OI Museum curator, and Edward Mazer, founding director of the Smart, in which Swift makes a reference to the state of the crude mending of the Venus and Cupid statue. And initial examinations of the object showed certain irrefutable evidence for the loan to the smart gallery. As you can see here, a paper label was adhered to the underside of the base of the object by the smart gallery. Also visible in this photograph are 3 pieces of cork that were presumably glued to the base of the statue in modern times to help it stand more stably. However, although Swift wrote that something ought to be done about the crude mending of the statue, it doesn't appear that anything happened conservation treatment-wise in the 1970s. As we saw before, the statue looks the same as the time of its acquisition in the 1950s. So knowing a bit more about the history of the object, or at least as much as we could learn, we started to examine the object in more detail in the conservation lab. The statue is made from an off-white colored stone that certainly resembles marble. It's been repaired from several fragments, and there's quite a complex break pattern. On the Venus figure, we can see joins at the neck, the right shoulder, the top of the right arm, the wrist, the waist, across the upper thighs, and at the shins. A break also extends across the Cupid figure at the top of the thighs. There's a yellow shiny adhesive in some of the joins, as you can see in the bottom image at the right. This adhesive appears to extend onto the finished stone surface in several areas. Also, a white material, likely plaster of Paris, was added at the joins in Venus's neck, shoulder, arm, and waist. And you can see a close-up of this fill material on Venus's waist area in the top right image of this slide. There are also breaks that run vertically through the statue, as you can see here. You can also see some unevenness to the color and surface quality of the stone. In some areas, it's lighter in color and smooth and shiny. In others, it's darkened and pitted, like on Venus's left arm and Cupid's left side. It's almost to the point where you start to question if these pieces even go together. But it's not unusual for archaeological stone fragments from the same statue to undergo different weathering processes, depending on where the fragments ended up buried in the ground. It depends on a variety of factors, including soil composition and degree of water that's around. So it's possible that these different colors that you see at the proper left of Cupid on the left image here, and on the torso and arms of Venus are just a result of differential weathering of the fragments during burial. It was clear from the outset that in addition to the discoloration on the stone, there are also remains of a reddish pigment in the folds of Venus's garment. Here. And here in this close-up before treatment photograph, you can see the remains of some red pigment on Venus's lips. In addition, we can see the condition of this previously carried out plaster fill at the neck and the right shoulder. This restoration work appears unfinished and honestly a bit sloppy. Perhaps whoever was carrying out this work was interrupted or unable to finish for some reason. The plaster clearly goes beyond the edges of the area of loss and is covering some of the finished surface at the neck. Here too, the plaster applied to cover the joints at the shoulder extends onto the finished stone surface, particularly at the underarm. And note this dark line here that extends over both sides of the shoulder joint. Another issue that we noted in the preliminary examinations was that the proper right arm joint was loose. It was possible to fully detach the arm, and so we did that, and it revealed that holes had been drilled into the stone surface on either side of the joint, and a metal pin had been inserted. Here's a view of that same area from the back. And here too, you can see that plaster is extending from beyond the break at the wrist onto the surface of the stone. This is probably a good point to talk about how art conservators today operate differently from the time that this initial mending and restoration was done. Art conservation as a profession is relatively young. While the Fogg Museum at Harvard had a kind of apprenticeship program in the early 20th century, the oldest university degree granting program in art conservation in North America, which is NYU, dates to the late 1950s. So it predates those early photographs we saw of the Venus and Cupid and the restoration that I've been commenting on so far. Training today usually consists of a graduate degree offered by a handful of universities, and the curriculum includes both theory and practice in material science, instrumental techniques for analysis of artwork, and hands-on practice. Above all, conservators today are required to adhere to a code of ethics that stipulate, among other things, the thorough documentation of conservation treatments, a commitment to use chemicals and products that are proven to be stable and reversible over time, and when it comes to compensating for losses, to not falsely modify the known aesthetic, conceptual, and physical characteristics of cultural property, especially by removing or obscuring original material. So a lot of thought goes into whether or not modern material, whether for adhering or compensating for losses, is applied. For example, intentionally drawing a pencil line on an object to mark where a join is just wouldn't be done today. The circumstances behind conservation treatments are now recorded in written form, and we create a detailed photographic record of what the object looked like before the treatment, during, and after. For example, here's a selection of the before treatment photographic documentation that I carried out before I treated the Venus and Cupid statue prior to its exhibition this year. There's also an equivalent amount of during and after treatment photographs. This documentation of conservation treatments is extremely time consuming, but also totally essential so that the next generation of conservation professionals responsible for the care of a collection will have as much information as possible about what circumstances precipitated the conservation treatment, what sort of treatment was carried out, what products or chemicals were used, and why. Unfortunately, we just don't have any of that documentation for the early repair and restoration treatment that occurred before the statue was acquired by the OI. I want to turn now to talk a bit more about the paint remains that were noted on the statue. I've already referenced the most obvious ones, the red color on Venus's garment, for example. Red is also visible on the lower portion of the statue beside Cupid's quiver. And here's a close-up of that dark red on Venus's lips. Dark red was also noted on the top of Venus's foot. And this detail image on the right also shows some of the adhesive residues I mentioned before, exuding from the join near Venus's toes here. We also noticed a pink pigment on the marble between Venus and Cupid and between Cupid's legs. Less obvious initially, but most certainly there were small dots of red pigment on Venus's torso, indicated by these arrows. We're fortunate in the conservation lab to have a digital microscope. Here I'm using it to examine and record some of the decoration on Venus's torso. This is a Dynolite microscope, which, as you can see, is handheld and allows the user to capture magnified images with a lot of flexibility. You can also see in this slide that there wasn't just red pigment on Venus's torso, but also what appears to be gold. On the right is an image captured using the digital microscope of Venus's navel, and you can see the vestiges of gold shining here. Here's another image of the torso where you can see both gold and red pigment. And here's another image of the torso area. And I think here you can see, particularly in the area indicated by the arrows, how the gold and red have been applied in the same area. It's possible that the red pigment was applied first and the gold was then applied over top of it. So the red would function as a bowl. In other words, it would have been applied as a preparatory layer or to provide a richer quality to the appearance of the gold that was applied over it. This technique was certainly known at the time the Venus and Cupid statue was made, and I'm showing here an example of a painted marble caryatid head from the site of Aphrodisias, which dates to the 2nd century AD. Gilding was found lying over top of red ochre in certain areas of the statue's hair, and interpreted to have been meant to display a sort of highlight in the hair. Similarly, there's this statue fragment of a leg, also from Aphrodisias, that shows gilding overlying 2 preparatory layers. First, a white calcium carbonate ground was applied, and then a red ochre. The gold was applied on top. And there's a cross-section showing these layers at the right in this slide. With the digital microscope, it was also possible to image the tiniest remnants of gold on this area of Venus's left arm, where there's a dark line, which suggests Venus may have worn a gold armband. Here's a more highly magnified image showing the gold. Curator Rocco Remora also noted a series of raised dots around Venus's neck, which suggests the remains of a necklace, which might have also had paint, although no paint is currently detectable with the naked eye or with the microscope. So the Venus figure would have originally been highly decorated. And here I've added some dots to this photo to help you visualize the pattern of this body jewelry. Rocco and Kirsten were able to confirm that this kind of body jewelry was not unusual for small statuary of this type from this time period, and provided several examples of comparable statuary, including this example, a Venus and Cupid figurine from the Ephesus Museum in Turkey. Another, perhaps even more compelling example is provided by this statue, the so-called Venus in a bikini from Pompeii that's in the Archaeological Museum in Naples. This statue has especially comparable gilded decoration in the torso and upper arm area. In addition to looking at the OI sculpture under the microscope, we also viewed it under ultraviolet light. This is a tool commonly used in the examination of art collections and can be very helpful when trying to evaluate the extent of previous restorations or any kind of coatings or adhesive residues that might be present on the surface. I had already seen a fair amount of a clear yellow-looking adhesive on the surface of the object under the microscope, but the UV light was very helpful in showing how extensive those residues were. For example, in this image of the underside of the statue that we saw earlier, in addition to the Smart Gallery label, you can see that there is some yellowish clear adhesive in the join line, and perhaps you can see that a bit of it is extending onto the stone surface itself. But under long wave UV light, this becomes a lot clearer, and you can see the extent of the adhesive residues is really quite significant. And you can also see some other details, like it looks like one of the modern cork feet was originally further back. In the region indicated by this blue arrow, you can see a cork foot-shaped circular residue of slightly more yellow adhesive. For some reason, this cork foot got moved. Maybe it fell off and got glued back on in a slightly different area. Many more adhesive residues were visible throughout the surface of the object. Like the application of the plaster, it looks like the adhesive used to glue the object back together was not applied in the most careful or clean way. And you can really see the adhesive residues fluorescing in this image on the right, particularly around Venus's foot and extending over toward Cupid's feet. Beyond these residues, however, we also noticed something else. The pink pigment that we had seen on the surface of the statue between Venus and Cupid's legs also appeared to fluoresce under the UV light. However, the dark red pigment noted on Venus's foot and on Cupid's quiver did not fluoresce. It's probable that this fluorescing pink pigment was made from the root of the madder plant. Pigments made from this plant are known to have a characteristic pinkish orange fluorescence under UV. This is an example from the Museum of Fine Arts Boston Cameo website, showing a small figurine with different shades of pigment from red-brown to pink on the front of the winged figure's garment. Under UV light, you can see the characteristic orange-pink fluorescence of the areas that were painted with madder. Madder was first used as a dye in Persia, India, and Egypt. And then its use spread westward, and it was commonly used in classical Greek and Roman times as both a dye and a pigment. So its presence on our statue is not surprising. In fact, madder was also found on the Venus in a bikini statue, seen at the left in this slide, as well as this other statue shown at the right, known as the Venus Marina, also from Pompeii. In addition to looking at the statue using UV light, we also examined it using the Conservation Lab's portable X-ray fluorescence spectrometer, or XRF. This machine is extremely helpful to us in conservation because it allows us to determine the elemental composition of the materials we analyze. In other words, it can tell us what chemical elements are present on the surface of an object. The best thing about it is that it is non-destructive. We don't need to remove a sample from the object we are analyzing. We can just hold the machine up to it and run the analysis. The diagram at the right in this slide shows how it works. Inside the instrument, there's an X-ray source, which fires X-rays out of the nose of the instrument. And those X-rays interact with the surface of the object being analyzed. The interactions are depicted in the schematic of the atom shown directly below the machine. X-rays from the XRF interact with the electrons in the atoms that make up the various elements on the surface of the object and cause a characteristic fluorescence, which is then read by a detector in the machine. Electron orbital structure is unique for each element on the periodic table. The energies that are produced during fluorescence incited by XRF by the electrons of each element are also unique, characteristic, and known. And in this periodic table, you can see all the energies listed out under the symbol for each element. For example, iron, which is indicated by Fe, has an energy listed at 6.405. The XRF then converts the energies into a spectrum that looks like this. It's a series of peaks, with each peak more or less representing an element on the from the periodic table. So you see in this particular spectrum, we have the iron peak at 6.405. We also have peaks for lead represented by Pb and calcium, Ca. This is a very simplified explanation of this instrumentation, and it can be quite complicated sometimes to interpret the spectra, especially when analyzing archaeological material, which is often heterogeneous and rarely perfectly flat, which are two criteria that are ideal when using portable XRF. But it still can give us some good information, and the fact that we don't have to remove a sample from the object is obviously a plus as far as the conservation department is concerned. One other thing to keep in mind is that the portable XRF spectrometer cannot detect elements below sodium or above uranium on the periodic table. So unfortunately, we can't see any of these elements with this technique. Here are some results of the XRF analysis for the Venus and Cupid figurine. The area of analysis is indicated by the blue square on the front of the base that Venus and Cupid stand on. So this is an analysis of the undecorated marble surface, and it shows mostly calcium, which is exactly what we would expect. Marble is calcium carbonate, and as we just learned, the XRF won't be able to detect the carbon and oxygen that's present. So we would just expect to see a big calcium peak, which is what we're seeing here. We also analyzed one of the patches of gold on Venus's torso, and you can see here characteristic peaks for gold with the symbol AU. We analyzed the red on Venus's right hip, and the XRF picked up mercury, which is the symbol Hg, and sulfur, the symbol S. This is a scan from the region of Venus's navel, where again, you can see the characteristic spectrum for gold, but also there are some peaks for mercury and sulfur in this region too. In the area of Venus's red lips, we also found mercury and sulfur, and the dark red near Cupid's quiver also showed presence of mercury and sulfur. We suspected that this red pigment containing mercury and sulfur was likely cinnabar, a pigment made from naturally occurring mercury sulfide ore. One of the limitations of the XRF technique is that while it can tell you what elements are present, it doesn't tell you how they all fit together into a molecule. So we can look at this spectrum and infer that because mercury and sulfur are present in the area of the red pigment, they probably are part of the same molecule, but we can't actually say for certain that we found the molecule of cinnabar. We can only say that we found the individual elements. So we decided to turn to a different technique for confirmation of the molecular structure of this red pigment. This is an image of a Raman spectrometer on the left. Raman spectroscopy uses laser light to create vibrations in the sample being analyzed. It produces a structural fingerprint by which molecules can be identified. A Raman spectroscopy analysis will produce a spectrum like you see on the right, which can then be compared with spectra of known materials, and so you identify your sample. The Raman instrument that we had access to required that a sample of the red pigment be removed from the object. So I took a tiny bit of red pigment from the top of Cupid's quiver. The image at the right, far right, is a picture of the sample that was removed, and the scale there is in millimeters. So it was a really tiny amount of sample. Raman spectroscopy is non-destructive in the sense that the sample is not consumed by the analysis, so we actually retain this sample of pigment in the lab. We were lucky to be able to work with Justin Gereller of the University of Chicago Materials Research Science and Engineering Center, who analyzed our sample for us using their facilities. The results of the Raman analysis of the sample from Cupid's quiver were consistent with cinnabar. So it's likely that the red paint that contained mercury and sulfur that we saw in other places on the statue, including Venus's lips and torso, are also cinnabar. Like madder and gold, the presence of cinnabar on the Venus and Cupid statue is not surprising, as this pigment has been used for decorative purposes as early as the 9th millennium BC. And there is evidence of it being used on marble statuary in the Roman period. For example, in this late 3rd century relief sculpture from the site of Nicomedia, Turkey, where the red pigment used to decorate the human figure's leggings has been identified as cinnabar. So despite its mostly undecorated appearance today, we've been able to confirm that at least 2 different types of pigment, pink madder and dark red cinnabar, as well as gold leaf, were used to decorate this statue. And it probably had a much more colorful appearance when it was first made than it does now. Unfortunately, the time and resources available to study this object in the run-up to the current exhibition were limited. There's a lot more analysis to be done, and we'll look forward to continuing to study this piece when it comes off display at the conclusion of the Making Sense of Marbles exhibit. And I just want to finish up this talk today with a summary of what was done in terms of the actual conservation treatment for this object. We decided to remove as much as possible of the unfinished marble plaster restoration that existed around the joins at Venus's neck, waist, right arm, and wrist. That material was likely originally added in an unfinished attempt to make the object look intact, something that's not a priority today. A before treatment image is shown on the left in this slide, and an after treatment is shown at the right. And again, this is before treatment on the left and after treatment on the right. Some close-ups here. I removed the metal pin that had been inserted between the joint at Venus's right wrist, as well as the white plaster, and replaced it with a modern adhesive that's been tested for reversibility and long-term stability. As I mentioned at the beginning of the talk, the item that Venus is holding in her hand is likely meant to represent a lock of her own hair, something that didn't quite work with the previous plaster restoration. Once that old plaster had been removed, we noticed there wasn't any connection between the lock of hair and Venus's upper arm, and we were concerned about the stability of the wrist-forearm connection. So a small amount of restoration, made up primarily of an acrylic adhesive, was added in this area to help stabilize the joint between the hand and the arm. And in this slide, you see the before view on the left and the after on the right. I also removed as much of the overlying adhesive residues as possible. This was very tricky in areas where there was pigment or gold also on the surface. So that work had to be carried out under the microscope. And in some cases, it wasn't possible to remove the adhesive residues, so some do remain. But much was able to be removed from the underside of the base, as you can see here. We hope, if you haven't already, that you'll be able to come and visit the Making Sense of Marbles exhibit at the OI so you can see this object in person, along with several other Roman marble objects from the OI's collection. Several colleagues helped with different aspects of the research and analysis of the Venus and Cupid statue, as well as the preparation of this presentation, and I'd like to acknowledge them here. And I also want to thank you so much for tuning in today.
For over 100 years, the OI has been a leading research center for the study of ancient Middle Eastern civilizations. Join us in uncovering the past and learn about the beginnings of our lives as humans together. Become a member by visiting oi.uchicago.edu/member.